Welcome to this presentation. In this video, we are going to discuss how to solve trigonometric equations. So the question we have here today reads, given that twice cosine of 2x minus 30 is negative 6 over 5, find x where the values of x range between 90 degrees and 360 degrees. In the question, we are given this equation, that is twice cosine of 2x minus 30 is equal to negative 6 over 5. First thing, we are going to eliminate these two by multiplying both sides of this equation by a half. So the left hand side multiplied by a half and the right hand side multiplied by a half. The equation simplifies to cosine of 2x minus 30 is equal to negative 3 over 5. Now next, we are going to solve this equation here. We are going to determine the values of x that satisfy this equation for this given range. And we are going to use the unit circle, particularly to interpret the sign here. So whether it's positive or negative, for our case it is negative. And before we use the unit circle, we are going to ignore the negative sign so that we are able to get the acute equivalence of 2x minus 30. And therefore we get the cosine inverse of positive 3 over 5, and that is equivalent to 2x minus 30. Cosine inverse of 3 over 5 is 53.13, which is an acute angle just as we had desired earlier on. So this acute angle together with the unit circle will help us determine a list of the values of x that satisfy this equation. So we proceed as follows. We state the unit circle. So the unit circle is a circle whose radius is 1 and it is divided into 4 parts known as quadrants. So we are going to read the quadrants in anti-clockwise direction. So this is the first quadrant, second quadrant, third and fourth quadrants respectively. So we label the first quadrant A. A stands for all trigonometric ratios. So here we have all trigonometric ratios being positive. And then in the second quadrant we label S. S stands for sine. Sine is positive in the second quadrant. Here only tangent is positive. Remember, if tangent is positive, the rest are negative. Here also, if sine is positive, the rest are negative. And here it's only cosine that is positive. Now back to the first quadrant. If we let theta to be the acute angle as we've determined for our case here, then the angle x, which we are to determine from the quadrant, is acute. So here we say theta is equal to x. X is the angle to be determined in each and every quadrant. So here x is acute. In the second quadrant, x is obtained as, that is the angle in this quadrant. We simply take 180 minus the acute angle. In the third quadrant, we have 180 plus the acute angle. And in the fourth quadrant, we have 360 minus the acute angle. Once again, theta for this case represents an acute angle. Now, the unit circle will help us solve this equation here by interpreting the sign. For this case, cosine is negative. That means the values we are going to use will come from the second quadrant where cosine is negative and the third quadrant where cosine is also negative. So we'll pick these two quadrants to help us. Well, back to this part, we are going to have 2x minus 30 degrees, and this time around it is not going to be equal to 53.13. Remember, 53.13 should give us the positive value, but in the equation here it is supposed to be negative. So the values that will give us negative 3 over 5 will be the values that we obtain when we substitute in these equations here as per the quadrants that we had identified respectively. So the left hand side we have 2x minus 30, and the right hand side we use the equation for the second quadrant, that is 180 minus acute angle, and the acute angle we have here is 53.13, and for the third quadrant we have 180 plus the acute angle 53.13. That simplifies to, so the first bracket here is 126.87, second bracket is 233.13. Now these are values that you obtain if we take our readings in one complete revolution. Now in the second revolution, we simply add 360 to these values we've obtained. So 360 to 126.87 should give us 486.87, and when you add 360 to 233.13, we also get 593.13. Now this list can be long. You can decide to move to the third revolution, fourth revolution, and so on. So if we move to the third revolution, we simply add 360 to this and that. So if we add 360 to 486.87, we have 846.87. Just like I said, the list can be long as you add 360 to the values you keep on obtaining. That is, as the cycles keep on increasing. So if we stop at this, hoping that the values you obtain here will give us all the values of x that fall within this range, let us now begin to solve for the value of x by equating the left hand side to each value on the right hand side. So 2x minus 30 equated to 126.87. Solving that gives us the first value of x as 78.44. That is 2x minus 30 is equal to 126.87 minus 30 crosses, so that we have 156.87. Dividing both sides by 2, we get 78.44. Applying the same to the next value, we are going to get 131.57. For 486.87, we are going to get 258.44. For 593.13, we get 311.57, and for 846.87, we get 438.44. Now, looking at this list, we realize that not all the values are as per this range here. So if you look at the first value, 78.44, it is less than 90 degrees. And if you look at 438.44, it is greater than 360 degrees. So what you're going to do here, we're going to eliminate the first one and the last one because they fall outside the range. And therefore the values that you are remaining with are 131.57, 258.44, and 311.57. And those are the values of x. So 131.57, 258.44, and 311.57. So these are the solutions to this question. Otherwise, I want to thank you for watching. If you're new to this channel, please make sure you subscribe and turn on the notification bell so that every time I upload videos similar to this one, you'll be notified. And also, please invite friends by sharing the link to this video so that you're able to learn together. Otherwise, once again, thank you for watching. Hope to see you in the next video. Bye.